after me. Today. Today.
Welcome to the second presentation of the spring 2023 season of the Medical History Interest Group Lecture Series. I am Eli Havaskos, an Associate Professor in the ECU Department of Chemistry. The Medical History Interest Group presentations are sponsored as part of the Ruth and John Moskop Lecture Series and Lapis Library History Collections. If you haven't already done so, please sign the attendance sheet before you leave. And we have refreshments, as you can see. Before we begin our presentation, I wanted to give you guys a little summary on the several history exhibits on display today. Here on the fourth floor, we have a pop-up exhibit related to today's lecture, featuring the patent medicine trade cards, homeopathic remedies, and other works from the history collections at the library and the Country Doctor Museum. We also have a fuller exhibit on patent medicines titled Bottles Full of Empty Promises, Patent Medicines, and the Advent of Modern Advertising. Also on display is the Scientists and Their Microscopes, right over here, which shows various microscopes in our collection with images of well-known scientists who use the same versions in their research. Finally, there's an artistic exhibit by ECU's Dr. John Hack titled Momentary Certainty, consisting of epoxy artwork reflective of the artist's 25 years of medical study. On the second floor of the library, to commemorate 300 years since pirate Blackbeard's adventures around North Carolina, we have The Plague of Piracy. The exhibit includes photos and artifacts, cast replicas on loan from the North Carolina Office of the State Archaeology and the Queen Anne's Revenge Lab. It is complemented with artifacts from the Country Doctor Museum, which I will remind you all is just off of 264 in Bailey, North Carolina, about 45 minutes away. And it's open for guided tours, 10 to 3 p.m., Tuesday through Friday at the top of the hour. It's a little plug. All right. And now for today's presentation titled, What Are in These Pills, Doc? Chemical Insights in the 19th Century Alternative Medicines. Our presenter is Elizabeth LaFave, a PhD candidate in the Department of Chemistry. I'm sorry, I got a small little intro and I kind of expanded a little bit, so you're going to have to bear with me a little bit. All right. Elizabeth is a PhD candidate in my lab in the Department of Chemistry here at ECU. I met Elizabeth as an undergraduate student in the senior level class, and I really didn't know she wanted to progress to go get a PhD. But through some weird circumstances and probably some good luck on my end, Elizabeth came to my office and asked to work with me. And I had just taken over as the Department of Graduate Studies director there, and I really wasn't sure. I was like, whatever, I don't know if I'm the right person. But I said, okay, I've got this weird DNA project, random DNA project for you to work on. Let's go try that. And so she did like unbelievable on that. And let's just say that's her primary project, which is a collaboration with the ECDUI over here. And she's figured out a lot of what happens to the early onset gene breast cancer 1 in the skeletal muscle system. Ugh, sorry about that. Through that work, she's been published in several chemistry and physiology journals, and her work is central to like an NIH grant we just put out. If that was her only project, however, we would not be here today. Elizabeth was a triple major here at ECU, and one of those was history. And so she's just naturally curious. She's very, very inquisitive, let's just say that. So a little backstory. One of my students, before she got into my lab, had this great-grandpa, I think, country doctor bag, and wanted to analyze the contents. And I thought that was pretty neat. And so I emailed Annie Anderson over at the Country Doctor Museum. And she just emailed me. She's just like the nicest person ever. And she's like, oh, come out and visit. And so we came out and visited. And while we never analyzed that original bag, Annie did give me like 2 kits to analyze, and she put them in these protective boxes, and we were all very museum happy, friendly, and everything. And I took them back to my lab, and I was like, all right, this is going to be cool. And I never did anything with them. I just sat in my lab. And then they called me back, and they're like, we need this stuff back, dude. You got to do something with them, so you get them back. And Elizabeth saw me like boxing them up one day, and she's like, what is that? And I was like, this is old Country Doctor Museum stuff. It's not the big deal. She's like, oh, that's interesting. What are we going to do with it? And she's like, I'm like, well, we're going to analyze it, I guess. And she's like, well, I'll do that. I was like, fine, here you go. And so we took a couple of pills out of the bottles, and they're kind of like the ones that are sitting over here. They're not quite the same kit, but similar. We figured out the ones that, she'll tell you a little bit, but figured out the ones we could get open. And we took some pills out, and so that was a Humphreys homeopathic remedy kit, and we packaged it up, and I gave it back. And really the rest of the story is Elizabeth's, and she's going to tell that. But I will say through these analyses, she's mentored, I think I counted this right, 8 undergraduate students. Is that correct? Yes, I'm right. 8, and then she's dragged us several other graduate students down there with her. So she's like this, she's like taken over this project, and she's like this PhD mentor person that is just like running her own little lab, and it's fascinating. She goes and gets these little pockets of funding and tries to keep going with this project, and it's just very impressive what she's been able to determine in this area, and I believe her work really helps shine light on like larger historical questions, which she'll get to. So sorry for the long-windedness, but as you can see, I'm super impressed with Elizabeth, and I believe you all will be too. So with that, here is Elizabeth LaFave with What Are in These Pills, Doc? And I'll give it over to you. All right.
Thank you, Dr. Vasquez, for that introduction. And thank you, everybody, for coming out today to hear my talk. Wait for this to load for a minute. And while it loads, I guess I'll tell you a little bit and expand upon what Dr. Vasquez was saying. So essentially it is true, there was just a kit sitting in the back of the lab. And part of that deal was if I got to analyze this kit, I had to mentor undergraduate students. So this is how we had this sort of overview of, and these are the primary, I don't know if it's going to show up on the screen, but listed on the top of the newspaper are the primary undergraduates that contributed directly to this talk. And so essentially today, we are going to speak about how our chemical analyses provided insight into this almost century-long evolution of medicine, starting with Karmer's apothecary kit in the 1840s and ending with our most recent analysis of female manufactured remedies in the later part of the 19th century and into the 20th century. So first off, to kind of give you a little bit of background about medical treatments in this era, this was during the Karmer's apothecary kit era. The premier medical expert was John Gunn. He was from Virginia, but essentially he kind of summed up this era as an era of quackery. So as you can see in this newspaper article right here, there was a lot of back and forth about what medicines were advertised and which ones would be the best. A lot of them were advertised to treat the exact same thing. So he kind of summed it up as these manufacturers were just after monetary gains. So James Karmer, who is from New Bern, North Carolina, he was a druggist there. This is our oldest kit that we analyzed. It's from the late 1840s to 1850s. And as you can see in the kit, these medicines per se don't look anything like the pills that we have today. So we have powders in here, ointments, and even a little yellow block that I'll talk about a little bit more later. And these are actually two excerpts from local newspapers that James Karmer put out himself. And they kind of display the sort of discourse that was going on in medical treatments during that time. As an aside, Karmer was not only a druggist, he also dabbled in agricultural supplies. And ultimately, his shop did burn down in the Great Fire of New Bern, which was around 100 years ago. However, we do have a picture of where his shop would be today and what's sitting there. It is on one of the primary commercial streets downtown, Pollock Street, and the arrow's pointing to the 58th block that his shop was on. So essentially what we did is we took a remedy. So for example, the white rock sample, we did a preparation step and then put it into our instrument here. It's called electrospray ionization mass spectrometry. And to give you a little bit of an overview, it goes through a sort of separation technique where the compounds inside the sample become charged. So they're called ions. They either have like a positive or a negative charge to them. And that's important for us because we're able to actually detect these ions based on molecular weight. So we can uncover things that we don't know what's in these samples, as well as validate things that they were labeled as. So was it actually true and what was in it? So to give you a little bit more of an overview of how this works, this is a standard sugar sample. So you can see the compound structure up at the top, and then its charge, or it's that what makes it an ion, so we can detect it. So usually, hopefully, the standard that you're looking at should have the largest ion. So that's 365 here. So that's sugar, we think. But we want to validate that. So we select in the instrument that 365, and we fragment it up. So think of a ceramic plate, and you're going to throw it on the ground, and it's going to make little individual shards, right? And this instrument basically does that. So these structures that we have beside the 203 and 185, if you'd put them together, you'd have your big sucrose ion that I showed on the first screen. However, unlike the plate smashing scenario, these shards are formed the same way each and every time. So that allows us to couple this technique with chromatography. So we're able to monitor the formation of those shards so we can actually do quantification studies or determine how much sucrose is in our sample. So like I said before, we analyzed Karmer's apothecary kit from the 1840s. It had a lot of different things in it. Over here on the side, you can see two of the undergraduate students that Dr. Vasquez mentioned earlier, Samantha Mills and Anna Vassallo. They actually traveled to the Country Doctor Museum to extract these samples. And we took 8 in total. They included rock samples here, as well as an ointment, and this sort of block-like yellow thing that we had no idea what it was. So this figure here kind of sums up 5 different samples. So it's based off that spectra that I showed you earlier where sucrose was, and we kind of just overlaid them all in a figure for ease of presentation. But each sample is represented by a different color. So for example, the white rock sample there is represented by the 2 red lines or peaks. And I have, for example, abiotic acid pointed at that 131. But when we go into this, we have no idea what 131 actually is. Assigning abiotic acid takes a lot of time and effort and thought. So basically, we select the 131, we break it apart into those shards. In the case of abiotic acid, it forms 113 and 89. And so we go in data banks and in chemical literature and try to find what compound matches up to those fragments because they're unique. So in this case, we found that those fragments might match abiotic acid. So we take it a step further. We get an abiotic standard. We prep it. We put it back through the instrument, and we make sure that it does, in fact, form 113 and 89 before assigning abiotic acid to that peak. So like I said before, this is a compilation of 5 different samples that we analyzed. So 3 were those sort of hard rock samples. So they're represented by the blue line, eucalyptol, the green line, liquoritin, and then the 2 red, abiotic acid and menthol. So it is a little weird that they're all supposed to be these rock samples, and 2 out of the 3 only really contain 1 primary thing. But then we have this abiotic acid thing. And abiotic acid is a compound in vegetable oil. So we went digging in some historical literature and found that during Carmer's time that a lot of these plants were processed as essential oils, and they were made using alcohols. And so we believe that the eucalyptol and the licorice root was prepped differently than the menthol or the white rock sample, just based simply on color, how they look physically. So the licorice root and the eucalyptol samples were this very dark brown, greenish, nasty color, while the menthol and the abiotic acid was this bright white tone. So we think that Carmer utilized alcohol, the licorice root, and the eucalyptol, killed the chlorophyll with the use of the alcohol, and they turned that color. Meanwhile, he used the menthol with vegetable oil. And we think that might have been because he also dabbled in farm supplies, so maybe it had a different use there too. Another little tidbit talking about the historical research that we do here. We kind of sprinkle in the historical literature to make sure that our identifications make sense. It's definitely not going to be some radioactive compound up there, right? So this little yellow resin block that I mentioned earlier that was on the screen, we read this memoir from an 1800s druggist, and he detailed that he made his little opiate-containing remedies through scraping bits of a yellow block into a medicine bottle. So we were very concerned there for a few weeks. I think I even emailed Annie and was like, do you think this could be what this yellow block was? It wasn't. It was tree sap. So completely safe. We also did analyze 3 powders in Carmer's kit. So only one was labeled. It was labeled as rhubarb. So that made our job a little bit easier. So we just didn't have to search kind of blindly for these fragments. We were able to simply take our analysis, look for the primary ion, and we kind of had an idea of what was in rhubarb. So Rhine here was at 285. We had a large 285. When we fragmented it up, those little shards matched what Rhine looked like. So we could easily say, yes, Carmer was telling the truth. In fact, this powder was. The other 2 that were eventually labeled as cloves and hibiscus by us, we had no idea what they were. So again, we did the same process. We took our initial analysis, looked for those large ions, and found, for example, 165 for cloves, or eugenol for this matter. And eugenol is found in cloves, so we were like, okay, it's probably going to be cloves. In history, cloves is used as kind of like a pain reliever. Hibiscus also makes sense here. It It's used for heart problems. So those kind of made sense. The chemistry matched, so we were good to go. Next up, we're going to delve into homeopathy, which was one of the large debates during the time period. So we actually analyzed two different forms of homeopathic remedies that stretch from the 1850s into the 1880s. So they were, like I said, two different types. One was administered kind of like Tylenol, so a person could just go right to their drugstore, pick it off the shelf, purchase it, and go on. The others, boric and tafel, were administered only by physicians. And you can see that they even look different, right? So here's Humphreys. His are labeled by ailment. So it had no ingredients list. So it was basically just this one, for example, chronic congestion. So if I was in the 1800s and I was congested, I would go pick up this one and take it home with me. Meanwhile, the boric and tafel remedies were all labeled by what was supposed to be in them. So this little insert here would actually tell the physician what that remedy would treat. So Humphrey specifics were produced by Frederick Humphreys, who was considered the father of American homeopathy during this time. So he was very much into arguing the principles of homeopathy. So those involved the laws of similars, as well as only using a minimal amount of whatever treatment he thought would cure or treat a symptom. So for example, if a person was sick, he believed that whatever would induce those symptoms in a healthy person should be given in a minimal amount to that sick person, and that would treat their illness. You can see here the variety of offerings he had for his little pills, that essentially they were going to treat anything from fever to worms. He did rely heavily on advertisement to kind of market his product on out there. Again, he has his little list of all the things he can treat with his specifics. And those types of advertisements for Humphreys actually continued into the 20th century. And finally, like I said before, he was kind of well established in his school of homeopathy. So he did publish numerous articles talking about the benefits of practicing homeopathy versus traditional allopathic or traditional medicines. So those would be something that would be considered more harsh by someone like Humphreys. And then we have boric and tafel. They came a little bit after Humphreys. They were two pharmacists that started this company. So they also had similar marketing strategies as Humphreys. They went to the newspapers. However, their advertisements were a little bit different. So instead of just listing their laundry list of ailments that they could treat, they decided to target how could homeopathy be beneficial and why it was the best way of treatment. Because remember, physicians administered these pills. So we did take a sprinkling of both Humphrey samples as well as boric and tafel samples for analysis. The lead undergraduate on this project, as well as the first undergraduate I ever worked with, is pictured here, Bronte Gerber. She started out analyzing these Humphreys pills. And it kind of looks like that we took a random sampling. We have everything for treating diseases of the heart to piles. But in fact, what we did is we took samples from the little vials that had loose corks. So we didn't want to destroy anything, or at least minimize our destruction. So there were 4 that were kind of easy to pop off, so those are the ones we went through. As a tidbit, the background image that I'm using, where you can see these little vials and these numbered corks, these are actually Humphreys pills. Then we have boric and tafel. Remember that I said they were packaged a little bit differently. They were also labeled differently. So boric and tafel's remedies were labeled by what they contained. So we took it upon ourselves to divide them up into 2 different categories, elemental and herbal based, which I'll explain that importance a little bit later, but just remember that we had no idea what was in Humphreys, and we had an idea of what was supposed to be in boric and tafel's. So yes, this is a lot of structure-like images. Probably not too fun for people that aren't organic chemists. But basically what this is saying, So pay attention to the little colorful figure here. We have these colored text boxes with corresponding structures. So basically what those text boxes are saying is that these are forms of sucrose that collected different charges when analyzed using the instrument, and they all relate to sugar. So we identified 6 prominent peaks, and 5 of them were sugar related. And this large figure here just basically shows how we know that all of these colored boxes are in fact sugar. But pay attention to this little yellow one, the 271. It is not sugar, it is apigenin. So basically what we did is we took that 271, we extracted that on the instrument, we broke it up, so created those shards, and found that it broke up in the specific pattern showed in figure A. We wanted to make sure though that it wasn't sugar, so we went ahead and selected the 271 and sucrose as well. Those fragments, as you can see, if you compare A versus B, do not match. So we went out and we bought an apigenin standard from one of the chemical suppliers. And we went ahead, we selected that 271 ion again, and those little fragments matched with those that we found in the Humphreys sample. So as you can see, in the figure, A and C are basically the same. So we know that Humphreys at this point had sucrose and apigenin in all 4 of the samples we analyzed. But we kind of wanted to know where Humphreys got this apigenin from, because we had no idea what it was before we did this little search for it. And we kind of stumbled upon apigenin by mistake after hours and hours of searching for what those fragments could possibly be. So we went to the Country Doctor Museum, and Annie offered to let us borrow some things from their herb garden. And we borrowed chamomile and mullein, because both of those are known to contain apigenin. If you look at the chamomile spectrum here, you see a large 285 peak ion. Mullein has a large 271. We know our target ion for apigenin found in Humphreys' sample was 271. So therefore, we were able to hypothesize that Humphreys probably got his apigenin source from mullein, which is a weed. So that kind of leads to that gun proposal that maybe they were just after monetary gains. Next, we use the same instrumental technique to look at boric and Tafel's 2 herbal-based remedies. So they were labeled, which was nice for us. One was labeled belladonna, the other rustox. So rustox is poison ivy. So we were able to do a quick literature search beforehand and know that atropine, for example, is a big component in belladonna and urushiol in poison ivy or rustox. So we kind of had an idea what to look for. So we basically just had to run our initial spectra and look for those compounds. So I have listed here the little shards that 290 or atropine formed, as well as urushiol. So we were able to identify that yes, Boric and Tafel did in fact label their remedies valid or true. And however, you do want to note that you see the large 365 peak ion up there. So that's basically ties into that initial example I gave. Yes, Boric and Tafel's herbal-based remedies did also contain sugar, but they contained around 15% gram per gram of their advertised label. Which brings us to our next category. So Boric and Tafel, basically we divided their remedies into 2 different sections. So we have herbal-based and we have elemental-based. We analyzed the herbal-based using the first instrumental technique I explained, the electrospray ionization. However, with the elemental-based, we had to divvy over and use a different mass spectrometry technique. In this case, we use inductively coupled plasma mass spectrometry to conduct elemental analyses on these samples. So it was nice that Boric and Tafel decided to label their little remedies. So we were able to have a predefined elemental search: arsenic, phosphorus, and zinc. So basically what happens after these samples are prepped, they enter into the instrument in the plasma area where they are essentially torched, which allows us to look for atoms instead of molecules. So we are able to detect the individual elements of interest with about the same way that I explained in the first instrumental technique. So again, just as a reminder, our predefined elemental-based remedies that we're looking for using ICP-MS are arsenic, zinc, and phosphorus. As an aside, when we first received these pills from Annie, we took notice that the elemental-based pills were very, 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 very small. So small that you really can't see it in the green tweezers there. So they are around 1/10 of the size of the herbal-based pills. So we had to use a total of 40 pills for each analysis we conducted. Typically, we only have to use 1 pill. So these are the undergraduate students that assisted on this portion of the project. They were actually taking instrumental lab with Dr. Vascos, and they were very interested in this project. Essentially, with that lab, you are allowed to pick your own research project and explore it throughout the semester. So again, they used ICP-MS to analyze 3 different elements: phosphorus, zinc, and arsenic. And this table kind of sums up what they found. So under sample, I have phosphorus, zinc, and arsenic kind of written out. Those represent the labels on each boric and TAFL remedy that we analyze. Across the top, we actually have the phosphorus, arsenic, and zinc that we measured using ICP-MS. And those numbers are in parts per billion. So essentially our findings were that these elements were very, very, very small amounts in these pills, and that they were all about the same. So we kind of return to the Humphreys mode of manufacturing here. So no matter what they're labeled, they all kind of contain the same thing. However, we do have an extra element here, lead. So how ICP-MS is set up, the standard that we use contains a lot of different elements. So we were actually able to not only look for the 3 that were predefined, but also some additional as well. And we found about equal amounts of lead in our 3 remedies as well. So the students actually took it upon themselves to come up with this hypothesis of why they saw lead in these remedies. So they looked in Boric and TAFL's medical index and found that they also produced opium at this time. So in that prep technique for opium, they oftentimes use lead. So the students concluded that this contamination probably happened way back in the 1800s when Boric and TAFL were manufacturing these pills, and not before the museum acquired these samples. So it was probably a Boric and TAFL manufacturing flaw. And finally, we are going to talk about the female manufactured remedies to sum up our turn into the 20th century. And we're looking at specifically Mrs. Persons, Winslow's, and Pinkham's pills. So to give you a little bit of overview about female pioneers during this time. So women weren't really looked favorably upon when they were in the medical community. This started way back in the 1700s, where midwives started to be replaced by less educated male physicians. So this kind of turned into something where female ailments were often overlooked in society. So some female manufacturers decided to take matters into their own hands and produce pills that specifically targeted those ailments. The first one we're going to talk about today is Alice Persons, or Mrs. Joe Persons remedy. So she conducted herself a little bit different than the other 2 I'm going to talk about. She didn't rely as heavily on forms of advertisement like the patent trading cards that are on exhibit here. Instead, she relied more on customer testimony. So she actually sought out physicians that could try her compounds on their patients, and if they worked, she detailed them in some newspaper advertisements for herself. She wasn't as well known as her counterparts like Winslow or Pinkham, but she did have some national recognition. She was featured in Julian Street's American Adventures, A Second Trip Abroad at Home. Lydia Pinkham, on the other hand, kind of liked her catchy slogans, right? So you can see here, men love peppy girls, and then appealed directly to her female customers, tired, nervous mothers. But she did incorporate some customer testimony into her advertisement. You can see here from the Evening News from California that her vegetable compound did in fact work. And finally, we have Mrs. Winslow, who is our best well-known female manufacturer. However, she's also the most controversial. So although she had international customers, by 1911, she was called a baby killer by the American Medical Association. And this was due to her syrups containing large amounts of narcotics and alcohol, and they were marketed to mothers for their children. We luckily did not analyze any of those. She changed her recipe after the changing tide in the early 1900s, where the medical community and the government kind of narrowed down on these manufacturers. So the two that we analyzed are pictured here. And one was soothing syrup and one was syrup after she dropped that soothing portion. And they actually came with inserts that stated clearly that they did not contain any narcotics. And they didn't. So this was our most recent analysis. Grace and Sink helped with these analyses. She's sitting right here. And basically, these are what those syrups, as well as Mrs. Pinkham's vegetable compound look like. So Mrs. Joe Persons is featured here, and then the two Winslows are right beside hers. They kind of look about the same, just a slight color variation. And then of course we have Mrs. Pinkham's, which was the only one in pill form this time. So this marks the first time that we've actually analyzed anything in a liquid form. So I'm using the same strategy to present this data as I used with Karmer. And essentially, this figure right here represents an overlay of two different spectra. So I overlaid the spectra for Mrs. Winslow's soothing syrup and for her regular syrup. They were exactly the same, so there's no difference. So basically, these remedies did contain a little insert that told us exactly what was in them. So for example, if you look at this insert, you can see Mrs. Winslow say the principal element is senna. So that kind of made it nice for us. We didn't have to do as much in the literature search as we typically do. So for example, we identified these intense ions in our figure. They're represented in colors here. And after identification, like for example 209, we took that fragmentation pattern again, looked for it in the literature, and found that it was anthraquinone. And then we searched for senna, found that anthraquinone was in senna, so it made our job a little bit easier because we kind of knew where to start and what to look for. Next up, we have Lydia Pinkham's vegetable compound. This marks the first time that we actually took our analysis a little bit further. So the others, we kind of topped out at that 500 range. And that's basically referring to sort of like the amount or the structure of compound that we actually looked for. But we were able to extend it out and find these large compounds as well. So you can see here at 677 in green that we've labeled this as an ingredient or compound in black cohosh. So black cohosh was listed on Miss Pinkham's recipe. We found that 677 is actually astin, and that is found in black cohosh. So again, we took it through. We found that Mrs. Pinkham's, yes, her recipe was valid. Hers did contain everything listed. Now, there's a striking difference for Mrs. Persons. And it's kind of small. I know these figures have a lot of lines on them. But if you look specifically at the 365 range, Winslow and Pinkham both had large 365 peak ions present. Person's does not, because hers doesn't contain any sugar. However, she does have pretty intense ions at, let's say, 371 and 355. So we found that 371 basically refers to fraxin. Fraxin is actually found in 2 of the different ingredients she listed in her recipe, prickly ash and Selengia. So that's why we think those are so intense, because it's actually coming from 2 compounds that or plants that she added into her syrup. So we basically summed up our analyses in this little table here. As I mentioned before, Winslow and Pinkham did have sugar in their remedies. So you can see here the amount of sugar that they did have. So Winslow's contain quite a bit more sugar than Pinkham, so around half for Mrs. Winslow. And then we also did decide to quantify the amount of active ingredients per se in each remedy. So how we did that, if you go back to the spectra that I was explaining, we identified, for example, astine or anthraquinone at a certain target ion. And from there, we were able to say, well, yes, anthraquinone is found in cinna. Mrs. Winslow's principal element was cinna, so we decided to monitor what we use to validate cinna's presence, and in that case, it's anthraquinone. And as you can see here, we kind of deduced that the amount of sugar is sort of the opposite of the amount of active ingredient. So for example, Mrs. Joe Person syrup contained the most of her active ingredient versus the least amount of sucrose. So finally, to sum everything up, we were able to apply our mass spec analyses into a historical context to kind of trace the evolution of medicine throughout most of the 1800s. And to do this, we kind of did strive to address some historical claims, or in this case, debates along the way. So first off, our large debate was homeopathy versus allopathy, or traditional medicine. If you remember, I talked about Humphreys, who was well recognized in this community. And he actually wrote out why he decided to use sugar in his elements. He used them for taste, as well as including vegetable medicines during times of bloom. But remember, we only found 2 things in Humphreys: pills, sucrose, and epigenin. However, we weren't able to actually get up to account for 100% of what was in these pills. So we decided to delve a little bit into the historical literature. We found that calcium carbonate was often used in these medicines. It's used for strong bones and teeth. And we decided to get a calcium colorimetric assay, which is basically the more calcium you have, the deeper color purple that you see. And we found that there was around 6% calcium gram per gram in each of Humphreys' pills. So it did contain sucrose, epigenin, and calcium. But we still really didn't understand why people were so motivated to take remedies that didn't really contain much and definitely wouldn't have helped them. So we actually decided to trek out on our own and go to the Tryon Palace Archives in New Bern and look to see what they had to try and trace back why these remedies were so popular after the Civil War. So we found a letter from the 45th Regiment Surgeon during the occupation of New Bern in the 1860s, and he actually requested the aid from a local physician, Dr. Bradbury. And we are assuming that local physicians, especially from small towns, would be more willing to actually use these alternative remedies than big city physicians that had exposure to traditional medicines. And finally, Another debate we were able to kind of enter into using our analyses was a comparison of male and female pioneers of medicine. So to sum up what we found, again, for the women, they had these laundry lists of ingredients in each of their pills or syrups. And yes, they did contain every single one of them. Some of them did contain sucrose, like Winslow and Pinkham, but they were still at much lower levels than their male counterparts, Humphreys and Boric and Tafel. So overall, we were able to use a modern chemical technique to kind of delve into the history world and answer questions of why people were so motivated to take these remedies, where most of them contains sugar, as well as kind of track what treatment options were available during this time and maybe try and answer these questions. So I do want to recognize a few people here before ending this talk. So this could not be made possible without, of course, Dr. Vascos allowing me to go pursue this museum research in addition to the BRCA1 research that I was initially supposed to do, as well as the plethora of undergraduate researchers that helped me along the way. Some of these slides were designed by them. And of course, for the staff at the Country Doctor Museum and Annie Anderson, the director, who has been oh so supportive of us the entire time. So we really thank you.
Thank you, Elizabeth, for a wonderful presentation.
Thank you.
So now we'll open the floor for questions. If you are joining us virtually, you can submit your questions to the email on the screen that you've seen throughout the presentation. And if you're here in person, I'll pass the mic around. We just ask that you use the mic so everyone can hear it virtually and on the recording later.
While watching this, thank you. While watching this, I was thinking about when you're doing your chemical analysis, if any chemicals, like you know how like when you get medicines or anything that you get, it says that it has an expiration date. I'm just curious if there's chemicals that would fade over time, like when you're researching this, if anything might have faded by chance over time.
So, for example, especially with the Carmer's apothecary kit, those hard rock-like substances, we are assuming that at one time they were liquids. We found that abiotic acid that is from vegetable oil, so we do think that those were originally oils and they did harden over time depending on storage conditions. However, the actual compounds themselves, as we detected, they're not that old in terms of half-lives and degradation. So in essence, we just don't compare our analyses to, let's say, modern day ingredients, because we can't really offer that, because of course the storage conditions are different, they're not optimal, and that's how we take that into consideration.
Hi. That was nice talk, very interesting topic. I just have small concern, like since we cannot confirm the structure by using only mass spectra, do you guys try to separate the mixtures, since I think it's definitely a mixture of components, right?
Yeah, so each remedy is a mixture of components. Mass spectrometry does actually allow us to separate each compound, and although we may not use the instrument with the highest resolution, we are able to actually select those ions of interest, just like with that sucrose standard that talked about earlier. We can select it, we break it apart, and those transitions into those fragments actually, they are unique. So they do confirm the presence of that compound. So each compound identified here was confirmed, and it is a well-recognized technique for confirmation analyses. Even outside, I know this is kind of a historical application, but we do also use that technique, for example, in DNA studies as well.
Thank you.
This question is coming from one of our virtual watchers. He asks on the first slide about homeopathy, the timeline, I think it said something like first effective homeopathic remedy. What is the definition of effective here?
Is he talking about the timeline on the initial? So I'll see if I can go back to that. So he's talking about this box right here.
I think the
For
top left
Humphreys,
one.
for Humphreys homeopathic. So basically, Humphreys was kind of the father of homeopathy in general in the United States. So effective wasn't something that we assigned, it was something that he actually advertised himself. So we were just kind of using his words.
Thank you.
Elizabeth, I just want to thank you for what you've done with our collections at the museum. We love you, and we just are so appreciative of your work. I just want to let everybody know that the work that you've done with our collections, I don't know of any other historical medical museum that's doing this work, so I think that really puts us up on an elevated level. But with all your research into the chemical analysis, the historical research, all the avenues that you've gone down to find this information, were there any surprises that you came across or anything that you really didn't expect? I know some of it was just in the dark initially, but was there anything that stood out to you?
So I think that the one that really stood out the most was our most recent analysis. So in the female manufactured remedies, Mrs. Person's syrup contained absolutely no sucrose, which is something that we had not seen since we analyzed Karmer's apothecary kit. But his kit was a little bit different in the effect that it was kind of used to make other medicines. So when we discuss the more popular medicines, we kind of tend to put his in a separate category. So I think Mrs. Person's was probably the biggest surprise because hers was so different than her female counterparts, as well as the male manufactured homeopathic remedies.
Just out of curiosity, I know with a lot of pills they were coated with a simple syrup. Was that taken into account with the different forms and how you had to take more of the homeopathic remedies versus the liquids as to how that would factor into the composition of the different elements?
So we do have to reach a certain intensity of the ions in order to get those shards or those fragments to use for identification purposes. So for example, like the boric and tafel pills with ICP-MS, we had to use such a large amount of those. But really with the rest, we kind of use the standard amount. It's around 0.04 grams diluted in 5 mils of a low or a higher pH of acid. So we kind of use the same prep technique throughout for all of them, except for those very, very small boric and tafel pills.
Did you, excuse me, did you find any of the pills that you analyzed, were they going to cure or at least help with any of the diseases they were listed for compared to modern medicine, what modern medicine says? And secondly, would any of them be very deadly? I mean, I know that arsenic and lead are not good things for people.
Yeah, so that's a really neat question. We were actually discussing this yesterday, where if you think back to that table that I had out with boric and tafel elemental analyses where you mentioned that arsenic was there as well as lead. So those are very, very small concentrations of those elements in general. But if you remember, the arsenic ones were actually in even a lower magnitude than the remainder of the other elements found. So during this time, arsenic was recognized as something that would be poisonous and deadly. There was a case of one of Thomas Jefferson's friends. He was a judge and he was actually murdered by arsenic poisoning, and it was recognized that yes, the doctors were able to say he was murdered by arsenic. So it was recognized during that time. So we think that might have been why Bork and Tafel also tread carefully when they had these elemental-based pills. But Humphrey's entire argument for his school of homeopathy was these laws of similars and to use such a small amount to not be harmful. So they kind of took that into consideration as well. And in terms of your other question about could they actually work today, so they're in very, very small amounts. So some of them, for example, like cloves, is associated as a pain reliever, but they're in such small amounts here that they really wouldn't do anything for you. So in essence, you're probably taking a sugar pill if you're taking a homeopathic remedy.
What about some of the non-homeopathic ones?
So for the female-based remedies, they do contain a lot of different herbs and things like that. We're actually still completing that analysis to see how much plant is actually added for each principal element. So if we could, we would apply it to modern medicine, but it's difficult for us because, as Marlena brought up before, things are stored differently. They may not be at the same levels that they were when they were initially manufactured. So we don't want to really make any assumptions as to, yes, this would work, yes or no. So we kind of just leave it there.
I have a quick question.
Okay.
So I know that with Lydia Pinkham's compound, she originally started making it in her own kitchen. Mm-hmm. And at that point, it didn't include alcohol. And it wasn't until she started selling it, it was added as a preservative. So I'm wondering if there's any way of knowing if it was more or less effective in either form based on the chemical analysis that you've done.
So we never really detect alcohol. If we wanted to have any luck with that, we'd probably need to branch out to another technique in general, instrumental-wise. But we could do those same quantification studies where we would look at Mrs. Pinkham's pills and find the amount of active ingredient in the pill and then compare it to the amount in the liquid as well. So that would be how we would reach those conclusions.
Thank you.
It's my question, not online.
Okay.
So this is all extremely interesting to me. Do you have plans for what you'll be doing next? Like if there is more research to be done on this topic that you'll be doing?
So this probably marks the end of my analyses for the museum because I am graduating. Thank you. But maybe one of the undergraduate students, like Grayson here, who has plans to go to graduate school, could pick up the torch and continue these studies. But Annie would also have to allow us to take a few of her samples that she probably won't ever get back.
Thank you.
Any more questions? All right. Well, thank you again, Elizabeth.
Thank you.
Thanks for everyone coming in today, and we'll close it out there.
Okay, thank you. Take this.